Okay, everybody. So welcome to our first official lesson for geometry for the year. We're going to be starting in chapter 1. And the very first section of this chapter is the building blocks of geometry. So this is going to be a lot of new vocabulary. And when I say new vocabulary, most of the words are going to seem familiar, but in geometry, they have some very specific definitions. So you can see on here, you're going to be learning things like angle, not today, but eventually angle, line, things like that you've heard those words before, but we need to make sure that we are all agreeing on what those things actually mean. So for today, this one right here, we're going to be talking about those definitions for the most part. Right. So we've got some vocabulary words here. Take a look at those really quick. For the most part, I'd be willing to bet that you've heard those words before. And we're going to focus in today really on the specific definitions in geometry, what those mean in the context of geometry. If you go back to the Canvas homepage, I've also included a template for a glossary that you can print out. If you don't have the ability to print that out, at least start your own glossary now. We're going to be using these words the entire year, and you're going to want the ability to look back at them. Okay, so our first one here in the building blocks of geometry is going to be the word point. Now, a point does not have a definition. Usually when we're here in class, I give everybody a chance to try to come up with a definition for the word point. And the problem here is, at this point, point is the only word that we have for geometry. We don't have anything to define it with. And so in geometry, we refer to these as the undefined terms, point being the first one of those. When we draw it, we always draw it with a dot, and then we label it with a capital letter. And the idea here is that you could think of a point kind of like a tiny, tiny little speck. It is basically infinitely small in every single direction. No measurements, no length, no width, none of that, just one specific place. Then move on to a line. And again, a line is another one of these things that does not have a definition in geometry. We kind of all just agree that a line is this straight, infinitely long thing. And when we draw it on paper in geometry, we draw it like this. We almost always use points to denote our lines. And so if there's a line that goes from point A through point B, we might call it line AB or line BA. And you'll notice that symbol above the top. It's a line. It goes forever in both directions. So we've got these arrows on the end. And they give you this example of a piece of spaghetti. But again, this doesn't have any width. It is infinitely small, but also infinitely long. And then our final undefined term, there are 3 of those in geometry, is plane. And a plane is kind of like the 2D version of a line. It goes forever in 2 different directions, like that way and that way. But it doesn't have any thickness at all. It's a 2-dimensional thing. And so their example of a plane is like a rolled out piece of dough, infinitely thin, but infinitely wide and long. And we're not going to use planes a ton, or at least not drawing them. But a lot of times what you'll see is this kind of cursive looking capital letter, PQ, something like that. Okay, 2 more definitions here. We're going to skip over the definition of definition because that is a little much at this point, I think. We've got 2 words here, collinear and coplanar. Collinear just means that these things are on the same line. And so they give an example of points A, B, and C all on a line. They are collinear. And the same idea with coplanar. If points D, E, and F are all on the same plane, they are coplanar. Just like in English, that co in front of the word means together. So when you say cooperate, you mean together. One very, very common thing here, the line doesn't have to be drawn. 3 points can be collinear even if the line isn't there. So keep that in mind while you see some of these. Okay, next up, we've got the word line segment. This is probably what most of you are thinking when you hear the word line, but in geometry, that thing is called a line segment. Basically, a line segment is the piece of a line between two of what we call endpoints. So they've got a point A and a point B are the endpoints. The line segment is everything in between. And what you'll notice here is we use the symbol AB with a line over top, line segment over top, no arrows at the end to denote that's different from line AB where we had the arrows. Now, I probably won't be too super picky about this next part, but it is something worth mentioning. There's a difference between AB, the segment, and AB, its length. So here I might say that segment AB is this thing, but its length or its measure is 2 inches. The segment itself is not 2 inches. The segment itself is this thing here, but its length could be 2 inches. So if you ever see that M in front of it, that's just telling you how long it is. And again, I probably won't be super picky about that, but you will see that in your book. Okay, let's take a look at this. This is illustrating the idea of segment addition. So let's see if you can figure this out. So we got Podunkville, Smallville, and Gotham City lying along a straight highway with Smallville between the other two towns. If Podunkville and Smallville are 70 kilometers apart, and Smallville and Gotham City are 110 kilometers apart, how far apart are Podunkville and Gotham City? I'm going to pause the video here, give you a question to answer, and we'll be right back. Okay, so hopefully you did not think yourself here. If the first two are 70 kilometers apart and the next two are 110 kilometers apart, then they're a total distance of 180 kilometers apart. Segment addition is just this idea that you can add up the little pieces and you get the whole thing. Kind of seems pretty obvious, but again, in geometry, we're starting with the basics here. We've got to agree that something that is obvious actually does work. Okay, now this is something that I will be really particular on. The difference between equals and congruent. So if we are talking about two segments that we know the length of, we could say that their lengths are equal. And that's where we'd use this equal sign. That's where we're literally talking about the lengths of those segments being the same. Now the segments themselves, the actual line segments, cannot be equal because they're not numbers. So what we have is in geometry is this idea of congruent. Now, two segments are congruent if they have the same measure. So these things are essentially the same thing, but congruent is the geometrical idea. Geometry was invented before this whole idea of a lot of these numbers like this. So if we're talking about the actual objects, we use the congruent symbol. If we're talking about their lengths, we use the equal symbol. Now, when we draw these figures to show that they're congruent, we use these things called tick marks. So in this picture, AB, this segment, and BC, this segment, are congruent because they both have one tick mark. Over here on this rectangle looking thing, might be a rectangle, might not, you can see that SP, segment SP, and segment RQ are congruent. They both have 2 tick marks, so you'll see that. Or if we put 3 tick marks on both of them, then they'd be congruent as well. And we'd write it out just like we did before. And this is read segment PQ is congruent to segment SR. And then I think this might be our last thing here today. Are these two words, midpoint and bisect. And these two are very much related to each other. The midpoint of a segment is the point on the segment that's in the middle. It is literally the same distance from both ends. Now, we say in geometry that that midpoint bisects the segment. And if you think about this word bisect, you've seen some of these words or pieces of these words before in school. The bi in front of anything always just means two. Think about things like bicycle. It means 2 wheels. And whether or not you recognize it or not, you've seen that second part too, sect. Probably in something like biology where you dissect something, cut it apart. Bisect just means to cut in two. So in this case, the midpoint of a segment cuts the segment in two. So if we take a look here, I want you just to think about it for a second. Which of these segments are bisected? And how do you know? So for example, I might say that F is the midpoint of CD. I know that because both of these two pieces are equal to each other. I couldn't say that F is the midpoint of EG. even though it looks like it's in the middle, we don't actually know that. There's no information there. Now, if I look over here, I could definitely say that K is the midpoint of JL. Again, it's marked congruent, so I know that that's the midpoint. What I can't say is that H is the midpoint of JL, because H is not even on the line segment. So even though it's the same distance from J as it is from L, it's not a midpoint. And then the same thing here as with the very first one. Even though N looks like it's equally spaced between M and P, without any information, we don't know for sure. So we can't say that that's a midpoint. That's just what that's saying. I'm not sure how that got in there again. Cool. Oh, I got one more. Sorry. Array. When I was in geometry, I always learned that a ray was basically half of a line. So a ray is a part of a line that contains one endpoint and then goes forever in the other direction. And you'll see here you've got an endpoint A, and it just keeps going forever. Now, something like this, you can name multiple different ways. The one rule is that you always start with the endpoint. So we could call this ray AY or ray AB. Either one of those are fine. What we can't do is call it something like BA. That's going the other direction. We need a ray that goes that way. Okay. So this one says look around your classroom. But what I do want you to do is to do step one really quick. Just look around your room that you're in and try to see some examples of things that look like points, lines, planes, line segments. This will be something that we will probably talk a little bit about tomorrow in our live session, is where we see some of these kind of things in real life. So pause the video here. I'm not going to have it pause automatically, but think about those things and be ready to talk about those tomorrow. Okay, so a couple little summary questions here. Are planes one-dimensional or two-dimensional? So think about that for a second. Are lines one or two-dimensional? And what do you think is true about points? So planes are two-dimensional. They have a length and a width, but no thickness. So 2 dimensions. Lines are one-dimensional, length only, no width or thickness. And points are actually 0-dimensional. They have no measurements whatsoever. Okay. This one's there's a lot in here, so think about this one for a second. Name all the lines in this picture, name all the rays in this picture, and name all the segments in this picture. You can pause the video and then start it up again. So, how many of you actually got them all? That's the question. Now, one thing you might not have known to look for, they have segment MA and they don't have segment AM. So if you had more than that, if you had MA and AM listed separately, that's certainly fine. That's not wrong. But, you might have seen MA, AT, and TH, but did you see from M to T being its own segment, or from M to H being its own segment? And then the last thing I'm going to have you do here is what's wrong with that statement? I think in my book, there's 2 things wrong with it for sure. Okay, so 2 things wrong with this thing. Very first thing is geometric figures cannot be equal. 2 lines cannot be equal. 2 line segments cannot be equal. The measures of those line segments can. So if we are actually talking about the line or the ray itself, we always use the congruent symbol, not the equal symbol. And then in addition to the fact that a line and a ray aren't the same thing anyway. So there you go. There's going to be another video for today for section 1.2. And then tomorrow during class, we'll be doing a little bit of practice on these things, some discussion with our in some groups, answering questions, making sure that we understood what's going on here. I know I've mentioned this before, but in general, those off days, those asynchronous days, meaning you're not on Zoom with me, those are going to be the days where you're looking at those new lesson videos. And then we'll use our time together, since we don't have very much of it, to help answer questions and kind of do some of the more interesting activities, I guess. So I will hopefully see you all tomorrow.